All right, so I'm gonna walk through some of the Linux command line. First of all, we're gonna talk about, I guess, what Linux is. You should already have this Kali VM, this Linux virtual machine pre-installed if you went through the pre-game resources. That's available in another video. You can sort of look at that, get a rough overview of how that's supposed to go. But we're gonna talk about what the shell is, the terminal. Oh no, that'll get me in trouble. Stop. Start again. Oh, well, it's fine. It'll be fine. What is a shell? What is a terminal? What is a console? They're all ways to interface with your computer. I've got a terminal right here called console, and it shows me some various, information by default. But otherwise, there's not a lot to look at. It's not a graphical interface by default. It's a textual interface. So I type information into it. I can, navigate my computer doing this. I can use this to start programs, so on and so forth. We're going to use the terminals that are available within Kali because that's a completely isolated environment. If you're on a Windows computer, the reason we have these virtual machines is so you don't have to worry about contaminating your host machine. If you break something in this Kali machine, it's not a problem. You can wipe it, start fresh. And that process is like maybe less than 5 minutes. So I'm gonna go ahead and just double click on my Kali Linux. And then it took over my screen. It's not full screen, it's just maximized. You can just drag it and double click on it to make it sort of go back big again. And while we're waiting on that thing to load up, we need to remember, if we forget our username and password to log in, it's all documented in the description. The username Kali, the password Kali. I'm just sort of switched back over to this other version. One useful thing, once we get in here, I double click it, you'll notice that it's going to stay small. If I type my username and password, once it's actually logged in, that's when the screen sort of becomes sort of responsive to the size and shape of this window. Now, again, we're using a simulated computer inside of a real computer. That's what these virtual machines are. Real quick lay of the land in this Kali VM. This bar at the top, you can call it your task bar. You can call it your start bar if you're coming from Windows. The point is, this button in the top left, that's your application menu. I might slip and call it a start menu periodically. That's just the way it goes. So I'm going to click on that. And like Windows, you can search through these particular options, right? So there's a bunch of folders that are sort of roughly categorizing the types of tools that are available in those folders. Okay. If I don't know what I'm looking for or where it's located, I can search for it. I know I'm looking for a web browser real quick. I'm going to type Firefox. And you can see that I typed Firefox, hit enter, and it showed up. I'm going to try to go to google.com. And this is just the quickest way to verify that you have internet connectivity. Can I do a Google search? Pretty straightforward. I'm going to search for cats. Why not? Cool deal. And the first thing I get back is the 2019 film. Excellent. All right, so I'm going to close Firefox. We've been talking about the terminal. You've heard about Linux in the past. Maybe you've heard that it's a text-based interface. What I'm going to do is I'm going to click right here. Or I'm sorry, I'm not going to click yet. I can click because this little black box, if you hold your mouse over it without clicking, it will say terminal emulator. Use the command line. All right. Another way for me to get access to it, if I click on the start bar or the start button, right? Remember that application menu, and I type terminal. And I have a bunch of different options. These might, work better for you from an aesthetic standpoint, but functionally, they're all going to be the same. I usually just use terminal emulator. You might hear me say, I'm going to press Control-Alt-T. That means I'm going to press the left control button, the left alt button, and the T button all at the same time, and that's going to make a new terminal pop up. So there's 3 different ways to open a terminal. All right, so a couple of things to note. If you're doing this in the Kali Linux 2021.1, they've gone to a version of ZSH, which is the Z shell. In the past, you might have heard of the bash shell, BASH. Understand that is just the thing you are typing into to issue a command to your computer. That's all sort of inside of the terminal, inside of the window that you're looking at is another program that you're using, ZSH in this instance, that actually relays the commands. Okay, well, what kind of commands are available to us? First things first, I'd say it's probably essential to understand how to get a lay of the land, like where are you on your own computer? They're going to give you some context clues, and I'm going to try to zoom in here. So right here, this little tilde, that means almost universally in all of the common shells, that is representative of the home directory. That's like your home folder. So what does that mean? What does that represent within the hierarchy of the file system? If I type pwd for print working directory, pwd, oops, I'm sorry, I didn't type it, pwd, you can see I'm in what they call the root directory inside of a folder called home. And within that, I'm inside of another folder called Kali. So it's a tree, if you will. And I think there's even a command. It's not installed. We'll go over how to install it later in a minute or two. But basically, the way that it's visually laid out, we can, I'm just going to maximize this. Oops. I need to be out of here. There we go. Okay. Let's get back to it. What was I saying? Oh, yes, the tree command. Not really a thing right now. We're going to make that installed here just a moment. Gosh, I've lost my flow. What did Zach say? Settle. Start over. Cut it out. All right. All right, so I'm in the root directory. I'm in my home directory, and you can tell that's by this indicated by this little tilde sign. This tilde sign represents the almost universally the home directory, and that means is I need to write 17. I'm just going to restart this whole segment. So. All right, so we're going, let me go ahead and pause. Okay, so there's 3 different ways to open a terminal. So I'm going to hit Control-Alt-T. You'll hear me say that a lot. And it's going to open up this window. Now I had it maximized, so it took over the whole screen. If you, again, double click on the title bar, or just like in Windows, you have the minimize button, the maximize button, the close button, same concepts. I made it as large as possible. So I'm going to shrink it down a little bit. Kind of resize it. And then I'm going to zoom in with the Control-Shift equal sign. Just like in Chrome, like when you want to zoom into a website, you hit Control-Shift plus or equals, yeah. All right, so what am I looking at here? I see that there is my terminal. That's where I'm at. I look at this thing and it's giving me a little bit of information. It's giving me my username, at my host name, my computer's name. And again, this is a simulated computer inside of a real computer. The simulated computer's name is Kali. And it tells me where am I within the file system. So the file system is, again, a way to store and organize information or files on your computer. There's a couple different kinds of files. There's files themselves, and then there are folders, which is really just a special type of file which points to a collection of other files. So if I try to figure out what this tilde means, again, I'm in my home directory. That's what the tilde means. PWD, print working directory. You can see I'm in a folder called home. And within that folder, I'm in another folder called Kali. Now, my username is Kali. It makes sense that I have a folder within the home directory that is all of Kali's files, the user Kali's files. So are there any other users on this computer? Maybe, right? It would stand to reason that they also have home folders. Well, they would be in the home, whatever that username is folder, if there are people actively using this file. And we'll look at the user accounts later. So right now, what if I want to look at some stuff that's on this folder that I'm in, or it's in this folder? How would I list the stuff that's in this folder? Well, I would use the ls command, or list stuff. I don't know that that's really what it stands for, but dang if it don't make sense. If I list the stuff in this folder, I can see that there's something called desktop, something called downloads, something called pictures, videos, music, documents. Those seem familiar, right? And if you had to think about it, those don't sound like actual files. Those sound more like folders, right? Well, that's because they are. How can I know that that's a folder? I have this visual indicator that it's blue, but that's not really the truth. Let me show you the truth about it. So it's ls tac. When I say tac, I mean hyphen L for a long listing of stuff. Okay. So a couple of things to note here. This gives you a bunch of information. It might be overwhelming, but what it does is it sorts it, or I'm sorry, it doesn't sort it. It displays it with a bunch of other metadata, data about the file itself, particularly the time that it was last modified or accessed and created and such. Who owns the file, and what group of people are responsible for it. And then it gives you these additional parameters over here. So these are what they call the Linux permissions. That's kind of we'll get into like permissions in a little bit more depth later. But the important thing to take away right now, that this is a folder, and I can prove that because it is a D at the beginning. The directory bit is set. Okay. So what if I wanted to go and look at stuff that's inside of my downloads? How would I go about that? Well, I can change directory, or CD, into the downloads folder. Capital DOWNLOADS. CD downloads. Now, Linux is case sensitive. Z shell itself is very forgiving. It will allow you to make a mistake and not capitalize downloads. So let's see. All right, what kind of stuff is in my downloads folder? How would I start to ask that question? Well, I would talk myself through the. I want to list the stuff that's in the downloads folder. LS. Well, it just so happens there's nothing in there. Kind of. I'm going to type ls tac L. Nothing still. I wanted a long listing. What if I want all the things? Tac A. I want a long listing of all the things. ls tac LA. And I see that there's now two little weird things in here. There is a single dot and a double dot. One period and two periods next to each other. They represent two different things within Linux. The single period references this current directory, things that are next to me in this folder. The double dot mean things that are in the folder above me. So in the folder I was last in the tree. So right now, dot dot is like a special pointer. You can see that it's a directory that points to a collection of files that I came from. So in computer science terms, you can kind of think of this as like a linked list, where you have a head, which is kind of where you are currently, and then you have a pointer to previous. right? If it's a doubly linked list, you can point forwards and backwards. That's kind of like the breadcrumbs along the top of some applications or websites that you go to. So how do I go back to my home folder? A couple of ways to do that. You'll see this a lot happening in scripts. You can type the relative path. That's what these dots are. They are relative to where you are, and they will exist everywhere. I will type cd period period. That's how I go back a directory. You can notice that it no longer says I am in tilde downloads. Tilde again represents /home/Cali. It's just sort of a shortcut for that whole home directory. And then /downloads. Now I am just in my home directory. I can prove that again by typing pwd, print working directory. All right. Let's see. What if I want to list all the stuff that's in this folder? ls, but I want a long listing. And just like the last time, I want to list all the things. Well, now I have a bunch more stuff. And I'm going to go ahead and make this window large again. I'm going to type clear to clear my screen. Start fresh. I'm going to do that again. ls tac la space tac la. And you can see that there are apparently a good number of files in here. Things that are related to the configuration of my user account, things that are sort of like hidden folders like they have in Windows to sort of have temporary working space for programs to sort of write things to and store their own configurations. That's what this .config is. In Linux, if you see a file that starts with a period, it is hidden by default. So if I see a folder named .documents, those are hidden documents. Well, how could I possibly make a folder that is hidden? I can mk directory. I can make a directory, a folder. Folder, directory, kind of synonymous. And what I have to do is I say mk directory, and then I give it the name of the directory I want to make. I want to make a folder called period, capital D, documents. All right. And I hit the enter key, and that's it. I've created a folder. How can I view it? How do I view things? I type ls. Shouldn't I see two documents? No, I don't. Remember, the period preface means that it's hidden. So how do I view that again? ls tac la. Now I see that there is not only documents, but documents. One of them hidden, one of them not so hidden. Again, I pointed out that this is created, this is like the timestamp at which it was created. So you could use that to sort of keep track of the newest things. If something was modified, you can say, oh, hey, that was recently modified. So the newest date right here is May 20th, and it is in fact 10/17. Cool deal. It's May 20th. So, all right. So what's the other stuff we can do? How do I go into that directory? Well, I change directory, period, documents. All right. Notice again, I'm CD'd into my home directory and into the folder. What if I wanted to make another folder? I'm going to do it. I'm going to do something confusing. I'm going to hit the up arrow on my keyboard. And what that's going to do is cycle through previous commands that I've typed. I'm going to make another folder inside of this folder called period, capital D documents. And Linux will let me do that. There's no problem with that. I can have folders within folders. I'm going to change into .documents. Notice what it's doing every time I go a layer deeper, it's adding. I mean, it doesn't have to do this. It's just nice that it does this. It helps us as humans remember where we are within the file system of our computer. So I'm in there. How do I get back to my home directory? I can type cd/home/Cali. That's one way to do it, and I can hit enter. That's my home directory. Let's see what happens. Those things go away, and my tilde is there. This is what they call an absolute path. This is precisely where I want to go. how do I get into this innermost .documents folder? This innermost .documents folder is in a folder called .documents. I would have to go giving a relative path, cd .documents. Ooh, and I messed up and I didn't tell you about that. I can use the tab key. The tab key is tab completion is your friend in pretty much any command line experience. What you do is you start typing a word, documents, and you'll notice that it kind of started filling out some stuff for me. That's looking at what I've typed in the past. If I hit the tab key, it'll fill out everything up until the point of differentiation. At this point, if I hit tab twice, it will, well, it should give me a list of options of things that I can continue to type. Obviously, sometimes it doesn't always pan out the way you wanted it to. I'm going to go ahead and cd into that directory, cd documents, tab key again, and I'm back there. I can also, to get back to my home directory, just type the cd, and it assumes that you want to go back to your home directory by default. cd.documents. It's another valid way to sort of bounce back and forth. So, how do I go about making new files? We're going to use a command line editor called Nano for sort of the sake of convenience, because it's right here, it's fast, and I think it's probably one of the easier text editors to get started with, and it's pretty decent. So it's Nano because it's small, right? Nano. And then I'm going to create a new file with this name. I'm going to say nano secret.txt. So what is this command going to do? If a file called secret.txt already exists, it will open it. If it does not exist, it will try to create a new file. There is no file in there called secret.txt. And so it's given us the opportunity. Now all we have to do is start typing our secret message. This is a secret, enter, message. I hit the caps lock key, MESSAGE, message, like so. All right, so how do I stop editing this file? How do I save my work and go about the rest of my terminal session? If you look along the bottom, there are a bunch of words, but you see like symbols in here. I see this caret symbol G, and it's next to the word help. Caret symbol O, write out. Caret symbol R, read file. Caret symbol W, where is. Caret symbol backslash, replace. Cut, paste, so on and so forth. These are the keyboard shortcuts you can use within Nano. Okay, so let's see. If I wanted to save my file, is there anything on that list that looks like save file? Unfortunately, there's not. They do have something called write out. That is save. Okay, well, how do I hit that key? Do I type the caret symbol and then the O? Unfortunately, no. What that caret symbol represents is the control key. And if you have a really old keyboard, that caret symbol, and I mean an old keyboard, that caret symbol, I think, was associated more closely with the control key. So if you'll hit Control and O, you'll notice that whole menu changes. And it kind of, this is like the user interface. This is a textual user interface, or a TUI, or terminal user interface. File name to write, secret.txt. Well, if I wanted to, I typed nano secret.txt. If I wanted to change the name, I can use my arrow keys to get back and forth, and I can type, anything else that I wanted to do. So I think that secret.txt is an appropriate file name. So what I can do is just hit the enter key. If I accidentally hit Control O and I wanted to go back and edit some more, I could hit Control C to cancel. And you can see that it told me that that's canceled. Second thought, I think I do want to save it. I'm going to hit Control O. I'm going to hit the enter key. And you notice it says wrote 9 lines. That means it was able to successfully write to the file system 9 lines of text. Well, this is a line, this is a line. Those are all real lines. They all exist within the file. And message is also the last line. So I wrote 9 lines, I saved something. How do I get out of this thing? Well, again, I hit the control, and then where's the quit? Well, there's not a quit, there's an exit. So I'm gonna hit Control X for exit. Make sense? All right. So now it looks like I'm back to where I was before. That's interesting. How do I look around at the stuff that's in this folder? Again, list the stuff in the folder. Notice that I typed capital LS and it told me command not found, because capital LS is not the same as LS. Okay. So that's what I was kind of getting at when I said Linux is case sensitive. ZSH will sort of help you out and be friendly. When I go into if I wanted to go into like a downloads folder, I don't have to always hit capital D downloads. I can just type downloads and it's kind of friendly enough. The only issue arises if you have 2 folders named capital D download and lowercase d download. How would we go about creating that scenario? Let's try it. mk dir capital D. I'm going to do test names. I'm going to do like capital T test underscore folder. It let me create that. That's a valid name. How can I prove that it exists? I can type ls to list stuff. Hey, and it looks like I've got secret.txt and now something called test folder. This is kind of what I was getting at earlier when I said there, it gives you a hint if it's a rule of thumb in the, in no way is this a law. If it's this color here, if it's blue, it's likely a folder. If it's green, it's likely a program. If it's white, it's likely just a regular file of some sort. It might be an MP3, it might be a Word document, it might be something else, but it's a file of some sort, not a program, not a folder. All right, so let's create that second test folder. So I'm going to mk dir test underscore folder. And it let me do that. There's no issue with doing that. What happens if I try to create capital T test folder again? It says make dir cannot create directory test underscore folder file exists. All right, that's what happens when you try to create a folder that already exists in that directory. If I type ls, I can see I have test folder, those are not the same thing, but if I cd test folder, which one am I going to end up in? Lowercase or uppercase? Well, my computer is going to do exactly what I tell it to do, and I told it to go into the lowercase test folder. And you can see as I hit enter, it put me in lowercase test folder. What happens if I wanted, what's an interesting way I could use sort of thinking of that list link concept in my file system? How could I go back to my parent and then to the other test folder? I think I can go cd space back a directory, capital T, or I'm sorry, back a directory / capital T test, and then I can hit tab and it should complete for me because it exists. If it didn't exist, it wouldn't have completed. So what happens if I hit enter here? You notice it took me back a directory to the documents and then into the capital T folder. All right, so we're running long on this. So let's see, what else can we do real quick? All right, so I've shown you listing stuff. What if I wanted to look at other things in my, like we're just been in our home directory, messing with our own files. What if I wanted to look at other places on the file system? I mentioned the root of the file system. That's that / right there. What if I wanted to look at the stuff there? I'm going to do ls /. And it tells me that there's a bunch of stuff in there. Great. We'll do a high-level overview of what some of these things represent. So home represents where all of the home folders for all the users exist. That's what that represents. Etsy, or I always call it Etsy, is where all of the many of the configuration files exist. Like if you have an application installed, then the way in which, rather than like going to the Windows registry or something like that, they will kind of exist as discrete files, as separate files inside of this folder. And they'll be organized in other folders. So it's a nest of folders, a hierarchy of folders. Other things that are of interest, media. When you plug in a flash drive on a Linux computer, in a modern Linux computer, and if it auto mounts, that is to say it automatically makes the drive like open and accessible to the user, it'll a lot of times end up in media. Opt is for optional programs. Root is for a special user. This is like the administrator. This is the administrator's home directory. This thing is confusing. I wish that they would come up with a slightly different title for it. But root is the folder inside of the root of the file system. If you think of it as a tree, this is the base from which all things grow. Okay. And then these folders, the collection of them serve as the trunk. And as you go up the tree, it fans out and it becomes, well, you know, a tree. Something that's interesting as well is the sys and proc. These are all information about the system and its running state. An interesting fact about Linux is that everything is technically a file. Every webcam that you plug in with USB is treated as a file that is either reading information or writing information. Every microphone is either reading information from your voice or, well, I guess a microphone doesn't do anything with like output, but all of those devices have some capability which can be implemented in terms of reading information or writing information. Your drivers for your display, your keyboard and mouse, those are files that you can look at and read and write information from. There is where a lot of like logs. So if something crashes on your computer, an application that we're going to run in the future, if something crashes, it might end up in this var folder or var, you know, whatever that is. And then where is USR? There it is, USR. I heard someone tell me that this actually doesn't stand for user, but Universal System Resources. And that makes way more sense given the stuff that's in it. So let's look at some of the stuff that's inside of USR, /ls/USR. I'm gonna hit enter. Now you will see this a whole lot. You will see /USR/bin/something. Let's look inside it. And this is like games might be universal. Includes is when you're writing software and compiling software. Some of the supporting files, the supporting code that other libraries have provided, those will be in includes, those will be in lib64, lib32, lib, so on and so forth. But once you have an actual compiled program, those are a lot of times available in /user/bin or /user/sbin, as in binary. Now, people use the word binary to represent the machine code once it's in a compiled state. But what does that even mean? Like when we go into ls, I'm going to go ahead and change directories into there. Let's do that. I'm going to cd/USR. Look where I'm at. I'm at /USR in the file system, cd bin, bin. Now I'm going to list the stuff in this folder, ls. Man, it filled up my screen. If you look really kind of faintly, there is a scroll bar. That's one of the nice things about a terminal is that it, like many other programs, like a web browser, you can scroll up and down if you scroll past something. There's a ton of programs available here. There's a bunch, because we're on kind of an advanced Linux operating system, it has a bunch of things pre-installed, and there's a bunch of like fancy manipulations that have been done, I'll call them fancy, in order to make certain things run. These are all files and folders. They're all technically files that serve some purpose. Some files are called folders, which point to collections of other files. I said that earlier. So we're looking at all of the programs that are available in almost all of the programs that are available in this computer, right? So let's see, what is, I think, what are some commands that we've typed? I want to ls, and I can look for a particular file, pwd. That I want to list the stuff in this directory that is named exactly pwd. What if I don't know anything? I don't remember the name of it. I can put an asterisk there. That asterisk is going to, what they call a shell expansion. And what that means is it's going to match anything that it's like a search, right? And it's going to match anything up until or after that, that asterisk. So I'm going to ls pw star. And now I see that there are at least 5 different commands that that start with pw, and you can see that it's pw hyphen something, pw in, pwd, all kinds of interesting things. If you look over here, you can see that even the shell that we're in, ZSH, is a command. It's a program that's running on the computer, and it's very meta if you think about it. Like we're looking at the program which provides access to other programs. Interesting. That's what the shell is. There's a zip command, and that's not this too different than the zip command on Windows. When you have a zip folder, you can unzip things, you can compress things, you can decompress things, send email, all kinds of interesting stuff. So we're not necessarily you don't have to know what any of these like commands are. Some that are interesting and super important really for you to understand is rm or remove. That's something. rmdir. What do you think? If this is to remove, what do you think this is? To remove a directory. All right, so let's see. I showed you nano. Something you're going to see a lot as well. I'm going to go, now that we've looked at the user bin, and I hope I didn't get too derailed there. I'm going to go back to my home directory by just typing cd. I'm going to use the echo command and what they call shell redirection. I'm going to take the output of one command and put it in a file. I'm going to type the echo command. Let's look at echo. Hello world. If I type echo hello world, it's going to echo back to the screen. It's going to put onto the screen the words hello. I'm going to echo hello terminal, and I want to append that. I want to add it to a file named, let's see, echo test.txt. And if I hit enter, what is this going to do? It's going to take everything that you saw on the screen and it's going to put it inside of the file echo test.txt. Boom. Notice that it did not go to the screen right here like it did here. It went into the ether. Well, how do I find it? ls. Now I see that I not only have folders, but I have a regular file. What happens if I list all the stuff in a long listing? ls tac l. I can see that I do not have a directory. I have a file modified at 1038, and this is showing you the size, right? So this is 15 bytes. One character should equate to, that's 1 character per byte. There's a couple of extra hidden things in there. There are new line characters, which you don't necessarily see, but they do have an effect on how the code, how the file is actually structured. That's just hitting the enter key basically. So how do I look at that? How do I put that onto the screen? Well, I could use nano again. I could type nano, and what did I call it? Echo.txt. Why did that show up so fast? I typed nano and then echo. I'm not really the greatest skilled typist. I rely heavily on my tab key. So should you. Nano echo.test. All right, cool. And I see the words hello terminal in a file named hello.txt. Excellent. How do I get out of this? Well, I look at the bottom and I have to just remember, this is one of them rote memorization things. That caret means control. Control, quit. I don't see a Q for quit. Oh, I do. I see Control Q and it says where was, but that's not quit. How do I get out? How do I stop? Ah, exit. That's what I'm looking for. Control X, exit. It's laid out, man. They make this easy for people to use, or if you're willing to reason about things, right? So that's one way. I can cat echo.txt. Now, why cat? Well, everything that I can come up with tells me that cat is short for concatenate, right? And if we're coming back from computer science, concatenate is joining two things together. And I guess you could sort of think of it as taking what's in this file and joining it with the existing information on the screen. Maybe that's a way to sort of rationalize it. So I'm going to cat the contents of the file echo.txt. You can see that it's hello terminal. Now, why would that be useful? Say I am running some program. I'm going to ping one time google.com. And I wanted to prove to a colleague that at some point in time, I was able to prove, I was able to ping google.com. So I'm going to call this proof.txt. Normally, when you run that command, you see output -c1. Right? And it gives you a bunch of interesting output too. And so we're going to talk about that later as well. This right here is one of Google's many IP addresses. This is a host name associated with it. You can tell a little bit about it based on the host name because we're humans and we want to use friendly names. I would assume this is Dallas Fort Worth. So that'll give you some loose idea of which data center you're touching. You know, roughly how long it took for the round trip down there and back, 20 milliseconds. And this TTL stands for time to live, and that has to do with how many routers it touched on the way down there and back. So let's see. All right. I wanted to prove that to somebody. Well, how would I do it? I would cat proof.txt. And I could save this for record in the future. Not just this command, but the output of many other commands as well. So saving output is a reason you would want to do shell redirection. What if I wanted to prove not only that I can get to google.com, but to msn.com? Well, oh, that was a bad example because MSN doesn't respond to pings. I'm going to say AOL.com. Actually, I think it's important to do this. I hit Control C right here. So this didn't actually run. You'll notice that I have this little red X. That means if there was some sort of error in the last command, there's a red X here because there was an error in this last command. That error was that I canceled it. This is all a feature of the ZSH shell. What is in proof.txt right now? Cat proof.txt. What I saw is I did actually have output ping msn.com. I have their IP address. Oops. I have their IP address, but I don't have any communication with them. So it actually deleted the stuff that was in that file the first time. And so what we're going to look at here is rather than overwriting, we're going to append. So I inadvertently did the thing I was going to show you, was that it overwrites content. Let's do it real quick with AOL.com though. Just to show, for the sake of completeness, cat proof. You can see that AOL.com for some reason resolves to Yahoo.com. Did Yahoo buy AOL? Likely. Or the other way around, I'm not sure. We have an IP address. We can see it took 243 milliseconds to get to that domain as opposed to Google, right? I want to have both of those things kind of side by side. I want to ping google.com. And again, I hit the up arrow to get to my previous command. I don't have to retype all of these things. all of the time. So I can type google.com, and then rather than sort of erasing everything within the file named proof.txt, I can add to it. I can add to it by adding an additional angle bracket. I have additional angle brackets to add to the file. Maybe that mnemonic helps. So let's look at it this time. I'm going to use nano rather than just putting it on the screen. I'm going to use the nano command to open it in the text editor. Nano proof. So you can see I have two identical-ish commands. I mean, the structure of them is the output of them is the same, but it's proof that at some point I was able to talk to AOL.com. I was able to communicate to Google.com. I've proven that I have internet access at this point by pinging Google, by pinging AOL. Control X. All right. So I mentioned that there are some hidden files, or I'm sorry, not hidden files, hidden characters, and that's the enter key, new lines, things like that. I want to actually not just look at the shapes, and this is an important concept, and I try to drill this in like computer science trainings for like the high school praxis and such. Disassociate the shape for the quantity 1 from the quantity 1. A good example of this is the Roman numeral 5 doesn't look anything like 5 units of 1. The Roman numeral 4 doesn't look anything like 4 units of 1. They have different ways different shapes to represent quantities. So when I see the number 1 right here, this in my mind is not the quantity. Depending on the context, it's not the quantity 1. This is just the glyph or the rune, the marking, the scribble that is the representation of the quantity 1. The same thing here. The computer doesn't know that like visually, once it's on the screen, it doesn't know that this 6 should be interpreted in context of this 3. So it's not looking at 6 and 3, it's 63. 6 and 3 might be 9, but 63 is an entirely different concept. So, or quantity. So bear in mind that we should disassociate the shape from the quantity. How are we gonna view that? I'm gonna type the command xxd. You could think of that as hexadecimal dump, maybe. I'm gonna do that with proof.txt, and we're going to see a lot of stuff. We're going to see exactly the same number of bytes that are in that file. How many bytes are in that file? I'm going to type, we'll type ls. I hit Control C. You notice that's why I got the little X and it went away without doing anything. I'm going to type ls tac l. Proof.txt is 555 bytes. Let's first look at echo test.txt. That's smaller. I think it might be easier to visually ingest. I'm going to type xxd echo tst. I'm sorry, echo underscore test.txt. I'm going to hit enter. What is it doing for us? This is giving it to us in hexadecimal dump format. This is something you'll see periodically. This gives you the row number in this column. This middle field is what they call the actual hex dump. And this last column is the, it's the ASCII representation, the printable character representation of the value represented by that byte. Okay, so what is the ASCII value associated with the letter H? Well, that's 68, the decimal value 68. Next is 65. That's the ASCII value for E. We get all the way through the word hello. HELLO. 20 is the ASCII representation of a space. It just so happens it looks empty, just like all of this other space over here looks empty. It's just coincidence that this is printable. This value of 20 is associated with the space character. Then we have 74 is associated with T, E, R, M, I. Oh, I'm sorry. Oh, I'm off by one. A, L. What is this? Is that a period? I didn't type a period, did I? Let's cat echo test. I did not type a period. Why is a period showing up? A period is like a placeholder character. It's very difficult to distinguish the placeholder character from the actual period. It's unfortunate, but it's just the way it is. I'm going to type nano echo test, and let's look at that. I'm going to go in. I'm going to add a period to the end of this sentence. I'm going to save my file by writing it out. I'm going to write out the file, Control O. I'm going to say, yes, that's an appropriate file name. And then I'm going to exit with Control X. Okay. Now I'm going to put the hexadecimal representation back on the screen. XXD echo test. What are we looking at? I see hello space TERMINAL 2E, that same 0A as above. I've inserted a new character, this 2 echo. That is the hexadecimal representation for this period character. So this 0A is actually the new line character. That has to do with pushing, just like the space key is a way to sort of change how text is formatted on the screen. Like I could type, this is a sentence, but it makes more sense if I add in spaces. You could figure out what this is a sentence with no spaces represents, but it's easier for the human to recognize it with spaces. The same thing is true of the enter key and the carriage return. So a lot of these terms actually come from old typewriters. If you think about an old typewriter, while we're here, I'm going to use my web browser. Linux is an operating system, just like Windows. You can do all the things you want to do in a Linux operating system as you can in a Windows machine. So I'm going to go to Google. I'm going to find a picture of a typewriter. Typewriter image, iMage. Twitter images. Dang, that's a $10,000 typewriter. All right. Okay, so as you're typing these on this old Olivetti key typewriter, so you have a carriage return. This carriage is the thing that actually progresses as you're typing. That's where your cursor is moving in your terminal. So as I'm progressing through writing example sentence, right? My cursor is progressing. When I hit the enter key, two things happen. On this old keyboard, what would happen is you would hit a carriage return, which is, or in some instances was a physical process using your hand. You would physically move that to the beginning and you would hit the enter, which would roll this page up, having the effect of putting you on the next line below. So visually what happened is if I started typing a sentence, Control C, and I'll do nano typewriter txt. This is on a line, and then I would hit a carriage return, which is represented by this /R concept. We'll say /R. What's going to happen when I do that is my cursor is going to go all the way to the beginning. When the computer encounters that /R, that carriage return, it says, okay, move the cursor to the beginning of the screen, to the beginning of this row, not the beginning of the screen. The next thing it will encounter is a /N. So at the beginning of the screen, oops, I'm sorry. At the beginning of the screen, jump down like so. So go to the beginning, go down. This is our line carriage. Turn followed by a new line. That's kind of what's happening. In Windows, this always happens. Windows has always followed this process. In a lot of Unix or Linux-like environments, sometimes the /n is enough. And what happens if we, now notice I didn't save that file, right? So if I look around, I don't have a typewriter or that text anywhere. I told it to exit and I told it not to save anything. Ugh, that's bad on me. Oh well, that means I'll have to redo that work. So let's see, what was I saying? Oh, new line, echo, hello, terminal, period. I can hand the output of this program directly to another program. That's through the pipe. I can send it along through the pipe. You go to the bank, what do? You take your hard-earned money, supposedly, and throw it into the tube and shoot it up and over, right? And it goes through that pipe to someone else for them to do something with it. That's an analogy I made up on the spot. Don't know that it holds true in every scenario. I believe it does. So I'm going to take echo, I'm going to hand it to the XXD program. It looks like we got roughly the same thing. All right. So this 2E, this 0A, the 0A is added automatically. How can I prove that it's added automatically? What if I send an empty string over to XXD? I get 0A and then an empty field all the way over here to this period. I can make echo not do that by using a -n. And then in that instance, it does nothing. There is nothing for it to send through the pipe, so it sends nothing. So that is that -n or the tack in, you could think of it as no new line. All right. Okay, so we've already pinged stuff. Let's look. I have my echo test. I want to look at the hexadecimal representation of proof.txt. It's going to be a big file. It's going to fill up our screen. Let's look at this. XXD proof.txt. Oh man, craziness, craziness, craziness. Look at the screen. It's blown out with everything. But those are all the ASCII characters. You can sort of tease it apart. PING space AOL period C, and then I don't know, where did I come from? C, and then I don't know where that is. 6F 6D space 28. There's some other characters that seem to be manifesting, and then I'm not, or I'm miscounting in here somewhere. All right, well, let's look at this. Let's do another trick. Remember how I said I could pipe information from one place to another? What if I feed that into the nano program? Oh, nothing happened. Let's see. Redo. This is at 110. All right. What if I feed that into the nano? Let me get that actually going again. Nano tech H. What if I feed that into the nano program? I can say nano tac H, and what that represents is the keyboard input. It's like it's taking all of this stuff and pretending that it's coming from a file called the keyboard, right? This is kind of a shortcut, kind of like the tilde is a shortcut to the home directory. This here. What did that do? that gave me the ability to put this into a text editor where I kind of have a little bit more control over how I can sort of cruise around the code in here. So I can see again, PING space AOL dot COM space open parentheses. And then I guess 31 is 1. 30 is 0. 36. Oh, so I'm sorry, coming back around here. 36 is the number 6, period. 1, 0, period. 2, 4, 8, period. 3, 1, 5, 0. Ah, yeah, absolutely. That's exactly what that is. I was trying to decode that in real time on my, like, thinking about it. I noticed a pattern. You can pretty much just drop the 3 in front, right? If you look at the ASCII chart, let's look at that. Oh, let me show you this trick. I really like having more than one terminal open at a time. Not a problem to do. You can do that. You can open another one. And drag them around. It's really nice. You can snap them as well. This. Well, and drag it over to the left side of the screen. Drag this one over to the right side of the screen. All right, for some reason, this one's not letting me do that. I don't know why, but there's that. Okay, so here we are. Ah, what happened? There it is. All right, so let's zoom in. Remember, with our Control-Shift+, what can I do? I can ASCII. Zoom out a little bit. Man stands for the manual, right? In ASCII, it will give you the ASCII characters encoded in octal, decimal, and hexadecimal. What we're looking at over here is the hexadecimal representation of characters. And you can see I just drug one window to the left, one window to the right, so I can have reference material on the right-hand side and my workspace on the left. If I look at this, and again, I'm using my keyboard up and down to sort of get around. If you look at the page, it's saying, showing line 25, line 26, line 27, show me where I am in the manual. I can press H for help or Q to quit. Tell me everything I need. If I look at this third column, and I'm pointing at the screen as if you can see that. If I look at the third column that's labeled hex, if I scroll down far enough, you're going to start to see things that you recognize. You see 20 is associated with space. Over here in our output, PING space, 20 space right there. So something to keep in mind. Same thing with these symbols. Something interesting sort of happens though, I think, when we get over here to 30s. So the 30 in hexadecimal is represented by, it represents the shape 0, not the quantity 0, the shape 0. 31 represents the quantity, or I'm sorry, the shape 1. 32, the shape of 2. All the way down, the same thing. 3F represents the shape, question mark. Same thing is true over here for the characters and the letters, so that the hexadecimal value 41 represents the shape of a capital A. Okay, so that's something to keep in mind. We're going to explore maybe some of that later when we talk about encoding and decoding. So hopefully in the computer science, like Praxis Prep and other things you might have been through, and one of the other advanced trainings, we'll have dived deeper into disassociating those two concepts. So I have looked at my manual. I'm done. If I want to close my terminal, I can type exit, and it goes away. I'm looking at this document over here. We've looked at everything we wanted to look at for right now. I'm going to go ahead and Control X, save modified buffer. No, I don't care about any of that. So let's see, what else is there? We talked roughly about permissions. Let's look at those one more time. LS, and I used a keyboard shortcut to make my window as big as possible. LS tac L, and I see that I have a couple of files. I'm going to write a quick script, that a shell script that does something, and I'm going to make it into a runnable program. I'm going to use nano, and I'm going to call this file quick.sh, as in quick shell script. Don't worry about the syntax of all of this real quick. This is just to show the file permissions, basically. Echo hello from the shell script. All right. Echo, this is also from the shell script. I'm going to do this. Echo with a capital E. This probably won't work. I'm going to write that out with Control O. I'm going to Control X to exit. You notice it said it wrote 4 lines. If I look and I run ls, I should see something called quick.sh. How do you invoke a program that's adjacent to you within the file system? Well, remember, period is for adjacent. This folder, period, this folder, something called quick.sh. You'll see this command. People will tell you, type period slash some program that you've compiled or downloaded or something like that. And it tells me permission denied. Well, I owned it, or I wrote it, I own it, right? I should have the ability to run it. Well, there's a permission that you have to change. Let's type ls tac l quick. Actually, I'm gonna, yeah, I'll go and do quick. Quick. If we look at this first column, remember it's not a directory. These columns here are broken down into a couple of things. It's the owner of the file, the group of people who are associated with that owner, and then the last column, or the last 3 groupings of 3 hyphens there, represent everyone that's not in those, that's not the owner or in the group of owners. Again, we have our number of bytes within the file, including the hidden characters, the control characters, things like that. The date that was modified, and the file name. I need to have read, write, and what they call execute. That's the position of all of these. Everyone right now can read this folder. I've created it. I've put no specific permissions on it, restrictions anyway, except for that I am the only person who can write to it. Myself and the root user. We are the only 2 people who can write to this file. If someone else logged into this computer, Dan123, and Dan123 wanted to read quick.sh, he'd be welcome to. He would not be welcome to make a change to it unless I give them that permission. How do I give them permission? I have to change the mode of the file. Change the mode, mod, change mod, chmod. You'll hear me say chmod plus X, chmod 755. I'm going to change the mode plus X to add an X for the user right here. Change mode plus X, quick.sh. And if I run that command from before by using the up arrow key, I go up a couple of times, I hit enter, you can now see that I have given everybody the ability to execute. Now, there's a whole complicated system of octal notation to give very fine-grained control. So say, for instance, I only wanted to give execute permissions to myself as well as people that are in my group, that middle column. There's a way for me to do that, and I can do change mode 775. And what that represents is that everyone should have the ability to, I'm sorry, not 775, it'd be 774. Yeah, 774. Everyone has the ability to read, write. I'm sorry, everyone in my group has the ability to read and write as well as myself, but everyone else has the ability to read only that file. So this is something, if you were making a public document, right? It's public, but only a select number of people are authorized to make a change to the document. People in a certain group, for instance. Quick.sh. Now, if I run that same command to list the stuff in a long listing, I can see that that last column no longer has the ability to execute the program, but they can read it. We don't have any test users or anything set up right now, so we're not going to go to the trouble of all that. But for the meantime, I guess let's try to invoke that program and see what it does. If I try to run it again like it did a couple of commands ago, right here, notice that it's, I'm sorry, it told me that permission was denied. I can type // quick, and again, hit tab. Actually, hold on, let's look one other thing before we do that. Type ls. Notice it changed colors yet again. It's now a different, it's a special file. That execute bit is significant. It makes it no longer just a plain text file. I can still open it with Nano. I'm using the tab key to sort of jump around through that list. I can still mess with it. I can still get it to do stuff. If I have it go now with this /quick.sh, I see hello from shell script. This is also from shell script, quick.sh:4 echo not found. Well, we kind of looked and noticed that something was amiss. If I go back to it, nano quick.sh. Echo, echo, capital E echo. It's not the same thing. Nothing exists on this computer called capital E echo that does anything. And I have an echo in the room, and that's why it keeps addressing us. So sorry about that. I can go and fix my mistake because it told me where it was. It told me it was on line 4:4, 1, 2, 3, 4. Line 4 is where my error was. I can write out my code, my changes. I can save them, and I can exit, and I can run it again. I need to update the text because it did in fact work. There's no reason for it to say this probably won't work anymore. So, all right, let's see, what else do we have? I showed you a little bit about the piping of output from one command to another. I think we're in a good spot like right now. I guess I haven't shown you any of like the listing of processes or anything like that. So PS, processes, you spell processes not with PS exactly, I guess, but print stuff that's running, I don't know. Processes, these are all the processes that I'm running in this terminal. If I wanted to look at everything that's running right now that I'm allowed to look at, I can type ps-ef. Now there's a bunch of stuff in there. Oh goodness. This is useful. It tells you the user ID, who's running it. I can see that root is running some programs on this computer. The administrator has some programs running. I can also trim this down a bit. So say I wanted to find only things that are referencing that only lines that contain the word KALI. I can pass them to the grep command. So I can take the output of this program and hand it to the input of this program. Grep, tac, and I'm looking for the word Kali. I only want to see things that contain the word Kali. If a Kali exists in this middle column for some reason, it should show it. All right. Well, it turns out that there's a lot of stuff running, but you'll notice that I don't see, after running this command, I don't see anything pertaining to root in this first column. Notice that unless it showed up elsewhere in here, which I don't see it showing up anywhere. Nope, I don't see it. So Only lines that contain Kali. Well, what about Firefox? I want to find out the Firefox command. Is there anything running called Firefox? Turns out that there is. So a couple of things of note here. Again, the user column, this is the process ID. So in Windows, you can go and you can kill a process, you can kill a task. That's what this column represents. This is what allows you to kill a specific process, not all instances of Firefox, not just a single tab, but all, or I guess you can kill a single tab worker. But let's see here. I'm going to do kill to kill a process. I'm going to type, let's see. I'm going to see 1981. So there's a hierarchy that sort of is passed through here. 1840 is the process ID. 877 is the parent process ID. Again, remember, parent, child, linked list almost. This is the main window. I know that just from experience because all of these other Firefox processes have a parent, a main window that is the same ID. This process, this process, this process. You've been using like Firefox or Chrome and you've like had it hang and crash. And it says, I think in Chrome it says, oh, snap. And then you can like press to reload that page. That means a process died. And the parent process was made aware of the fact that the child process died. Let's kill this one, 1965, 1965. Okay, let's look at Firefox and see how it handled that, if it handled it. Maybe it didn't. Seems like it didn't care for it. Oh, it might have come back so quickly because I see that there's a 1981 now process. Let me go back up. 1981, 1965 is gone. Let's kill 1981. Kill 1981. Ah, it's not doing anything for me. So what about 1840? Ah, okay. You can notice it in the background, Firefox, the whole Firefox thing went away. So I killed the parent process as well as some of the worker processes in the background. So, all right. I mentioned a little bit ago, I'm going to do this, that we could install a program. Let's look real quick at the how to do that. You were going to use the apt program, the apt package manager, apt, and we're going to install something, install the program that we wanted to install. I remember that we were going to look at the word, the tree command, tree. It says tree not found, but can be installed with sudo apt tree. They even tell you what you should type. If I type just apt install tree, it's going to tell me that could not open lock file located in this particular place, permission denied. Unable to acquire dpackage front end, dpkg front end lock, yada yada, are you root? There's a reason they told me to run this sudo command. Sudo, I mentioned that root is the administrator. Sudo is a way for me to run a program, run a program as an administrator. If I rerun that command, I'll hit the up arrow. I'll go to the beginning of the line and I'll type sudo. That's going to say, run this command as if you were the root user. I'm going to hit enter. This time, rather than just failing, it's asking me, what is the password for your user? So it might seem kind of backwards. I'm not giving the administrator's passwords. I'm giving my user password because the administrator has said, you are responsible. You have the ability to run programs as if you were me, the administrator. But in case you walk away from your computer, we're going to make you type in your password to confirm that it's actually you. You know what you're doing. Again, if you walked away from your computer in an office environment and somebody came through and tried to just sudo apt install some program, this would sort of act as something of a layer of defense or a sanity check to make sure that they aren't doing something they're supposed to be doing and that you are reminded, oh, I'm supposed to engage with a higher level of, cautiousness when I'm installing programs. This is my password. My password is Kali, K-A-L-I. I'm going to hit enter. Now it's going to go through a bunch of information. It's going to give me updates about what it's actually doing. It's going to say it's downloading certain files, fetching things, that is to say. Now it's processing, it's unpacking things, so on and so forth. Now, if I were to type the tree command, T-R-E-E, I have a different representation of my directories. Rather than just listing the stuff, I have kind of a hierarchy. I wanted to find out more information. I want to actually see, I mentioned there was like an analogy of a tree at the root of the file system, and then we have the trunk, and then as it grows, it sort of fans out. I want to find out how to make it do that. Tree, and I want to get help with how the tree command works. --help. It filled up my screen really quickly with a bunch of things I can type. So let's see. I want to oh, file name. I'm looking for this because when I typed tree, I was expecting it, like, be perfectly real with you, I was expecting it to show the nested nature of it. So what I'm looking for here is some context for like having it show, additional folders or folders within, or I'm looking for recursion. Recursions when you do the same process over and over again, to have it do something recursively. So reverse the order, sorting options. For some reason, I can't scroll very well. Okay, let's see, non-printable characters. All right, I'm looking for, let's try tree. What did we call? We had something called .documents. Zero directory, zero files. Is there a tac R? Tree -R. Ah, that was it. Tree -A and documents. Okay, so now that we figured it out, what we were looking for in our commands, let's go through our help one more time and see if we can't find it. Tree -help. If I scroll up, there was a -a, and man, why is this thing not wanting to help me out and scroll? -A, and I missed this earlier. It says all files are listed. -A for all the files. Pretty on the nose. And I say I want to show a tree of all the files in a certain folder. By default, I guess it assumes that if I hit .document, it'll assume like the current directory. If I hit .documents, that's how I can say specific, folder. Something else of interest, I think there was a -L level, descend only so many level directories deep. So you'll notice in practicing there, I came up with something that sort of clobbered the entire screen. So if I go tac L and I say 3, oops, I'm sorry, 3. That's not going to go any more than 3 folders deep in any particular folder. I'm going to go ahead and even go to 2. And I want to look at the root of the file system. Let's see what happens. Okay. So I'm seeing a bunch of stuff, and you can sort of see how it's all sort of lined up. These folders here, all of these blue things are, again, kind of representing folders. They're all within the proc file system. Media, CD-ROM, remember I mentioned that was kind of like for removable media. CD-ROM lives within the media folder. I think home directory has a folder called Kali. And all of these things, if I scroll up far enough, we're going to see the root of the file system, the slash, and then all of its, children folders. So, I think that's, gosh, we're like an hour long video. Jeez. Okay. Let me call it quits for right now. Let's see, what else did we not do? We didn't actually delete anything. I'm sorry. I'm going to remove this file. I'm going to remove this file called nano.save. I'm sorry, not nano. I'm going to remove rm nano.save. Boom, it's gone. How do I get it back? And don't remove things you care about. Okay, there's not much recovering from it. At this stage, there's not. Cats. Let's see. Quick.sh. I put that onto the screen. That's essential. I'm going to do this real quick. Sudo chown root. All right, so I ran that program a little bit ago. /quick.sh. Now I'm not allowed. I said only the root user. What I did here, I typed ls tach l. You'll notice I didn't actually type that. I typed ll. That's a shortcut, an alias for a long listing. Something you too can do, right? But it's good to remember because that doesn't exist everywhere. That ll is just a nicety of Kali Linux. Not all Linuxes have that. Not all shells have that feature. Not even all versions of Kali have that feature. It's really more of a ZSH, like a newer thing they've added in recently. Not a ZSH specific thing, but a newer alias they've added. So ls tach l will exist. Oops. And I hit a quote, and I'm just going to hit Control-C to cancel that. What am I doing here? If I look at the permissions of this quick.sh, you'll notice that root owns it, not Kali anymore. Like Kali owned proof, Kali owns echo test. It does not own quick.sh. And who's allowed to execute in the everybody group? I'm no longer the owner. It's just in my folder. I don't own it. I'm holding it for a friend, as the kids might say. And root would, I'm sorry, not root. Everyone else can read it. I can look at it. Cat quick.sh. I can put it on the screen, but I can't run this program. So good for like something, I guess. All right. Like I said, I'm going to stop the video now, and hopefully it will be of value to you in your self-study. So, all right. Oh, we can shut down. No, one more thing. Shut down. You can quit by going to the top right, and you can shut down if you're ready to, stop. It looks like a little power icon. Oop. You can shut down. You'll see that it'll go away pretty quickly, and then that's the end of the Kali lesson. My goodness, it's been an hour and 40 minutes or so. Let's go through and learn stuff or something.